Good morning, my YouTube viewers. In this video, what we're going to talk about is the Pearson correlation coefficient. So this is also part of statistics as well. And the reason why is before they had linear regression in machine learning, which is where most people find it. Before machine learning became popular, you had statistics. And so linear regression was part of the statistical model. So this is what we're going to talk about is the Pearson correlation coefficient. So the Pearson product moment correlation coefficient is a statistical measurement of correlation, that's linear association between two sets of values. If the correlation value R is close to +1, this indicates a strong positive correlation. If R is close to -1, this indicates a strong negative correlation. And then you also have something called covariance. Covariance measures how two variables change together. It tells the user how increases in one variable tend to be associated with increases in another. Covariance has no fixed range of values that it can return because it depends on the scale of data. Covariance can be any real number, being positive, negative, or 0. So what I've done is I've made a practice question to talk about Pearson's correlation coefficient and covariance. So what we're going to do is we're going to equate the hours studied with the exam score. So we have hours between 1 and 11 and 1 point increments, and then we have exam scores between 50 and 100 and 5 point increments. So basically the idea is that the more hours you study, the higher your exam score is going to be, because people that studied 1 hour only got a 50%, whereas people that studied 11 hours got 100%. So the more you study, the higher your exam score is going to be, or that's the idea anyway. So we're going to calculate Pearson's correlation coefficient. So you're going to say coral brackets A3 to A13, comma, B3 to B13. So the A column is your X variable, that is your independent variable, and your B column is your Y variable, and that is your dependent variable. So the Y variable is dependent upon the X variable. And now we check Pearson's R, so Pearson's correlation coefficient. So Pearson equals A3 to A13, comma, B3 to B13. And then we check for covariance, equals covar A3 to A13 to B3 to B13. So we can check this. We can say, just change this to 40. And you see that the Pearson's correlation coefficient and the Pearson's R is still 1, but the covariance changes to 55. So we'll change it back to 50. And you can see that the covariance changes back to 50. So whenever you change the values, we'll just leave this at 95, or make this 99. And you see that the Pearson's correlation coefficient and the Pearson's R stays at 1, and the covariance is 50, but we'll change it back to 100, which is what it was originally. So you can toy with the values, and that will give you a different Pearson's correlation coefficient, Pearson's R, and covariance. And what I've done is I've made a chart of the exam scores. So you've got your X variable being 1 to 11, and you've got your exam score being 50 to 100. And what we can do is we can say format plot area. And so we can say horizontal value axis, and try it on the histogram. try axis options. So you can try a logarithmic scale, see what happens, but it's not a logarithmic scale. You can try your tick marks. You can try your labels. And you can try number. But obviously I didn't find what I was looking for. So let's try this, trend line 1. Exam score 1, trend line 1. So you've got your trend lines. You've got your trend line name is automatic. It's going to be linear. And then now you can do a set intercept. And then you can display equation on the chart and display the R value. So what that does is that makes your chart have a little bit more information in it. So you've got your trend line, you've got your equation, and you've got your R value. So that concludes the video on Pearson's correlation coefficient. The next video is going to be on simple linear regression, and I hope that you decide to watch it.